Understand the next STL container that we want to cover, which is map. Imagine that you're storing sports stats in your application. So something that looks like this: player's name, the number of matches they've played, the number of innings that they've played, the number of runs that they've scored, and their batting average. Where would you store this? You probably create structures for each player and then store these in an array, and then you'll need indices to access each of the player's records. But you'd have to search by the player's name every time you need to look up some record. So, for example, if you want to determine how many runs Jack Callis stored, then you'd have to search through this array for the name Jack Callis and then look up the correct column. But wouldn't it be nice if we could do something like stats and then array indices and then specify the name of the player in it? That would be fantastic. That's exactly what the map data structure does for us. And the way it works is it uses one of the columns as the so-called key. So the player's name would be the key in this case. And the rest of the columns are the value for the corresponding key. So we say that map has key value pairs stored in it. So it's a collection of key value pairs. Um, and you look up a value using the corresponding key. So let's see some code. Let's try to create an email directory. So code. We write a main function and I'm including the unordered map, which is a type of map. And I'll have more to say about what this unordered part means. But I create an instance of type unordered map, and I am specifying two things inside the template parameters. One is the type of key, and the other is the type of value. So in this email directory that we're trying to create, we're going to create a mapping from a person's name to their email address. And the name happens to be of type string, and the email address can also be stored in type string. So we create that unordered map, or we define a variable of that type, and in that map, we are storing the values on lines 10 through 13. So we say the name of the map, which is email directory, and inside the indexing operator, the square brackets, we specify the string, which is the key. So John Doe is a key; it's the name of a person, and we use the assignment operator to set it equal to the string john.doe at example.com. So this is how we create a key value pair and store it in a map very, very conveniently. This part, once again, is the key, and this is the corresponding value. When we create other pairs as well, we say that Jane Smith has an email address of jane.smith at example.com. Alice Johnson has an email address of alice.johnson at example.com. And Bob Brown has an email address of bob.brown at example.com. Fantastic. We've created that email directory. Now let's see how we can look things up in there. So let's say I create a string, and the purpose of this string is to search for an email address by name, and I store a name in it, let's say Jane Smith. And the way I look up um, a value in this unordered map, it can be done in many different ways. And one of those ways is to use the find function. That is a member function of the unordered map class, and it accepts one argument, which is key, which is the key. So here's our map dot find, and this is the key that I'm looking for, which is the value of the string Jane Smith, and I'm checking what the return type of this um, find function call is. If it is not equal to email directory dot end. So just as remember that we talked about vectors and we said that the dot end function returns an iterator which is beyond the end of the vector. This is very similar as well. email directory dot end means that I was unable to find this particular key in the unordered map. If that happens, I say that the email for this person uh, was found, and I look it up by saying email directory, which is the unordered map's name, and inside these square brackets, I say the key. So just as we were able to store a value corresponding to a key using these square brackets, we can also look up the value uh, using these square brackets by inserting the key inside those square brackets. But if that is not the case, and the find function actually returns a value that is equal to email directory.end, then we say that this key was not found in the directory. Now, if you wanted to display all the entries in the unordered map, there are various ways to do that. And over here, I'm using the model C++ range-based for loop to do that. I'm using the auto type specifier to let the compiler figure out what the type of the elements are going to be. But this is the most essential part of the range-based for loop. Uh, this part is the name of the container, and separated by the colon is the uh, variable name pair. So every element from this container is going to be fetched, and it's going to be its reference is going to be stored inside the variable name pair. Its type is determined by the compiler. I am defining these to be references, and I'm also defining it to be const so that I can modify them. How do we deal with this pair object as we iterate over the unordered map using the range-based for loop? Every element that we fetch from this unordered map is going to have two parts. One is the key, and the other is the value. The key in this case is referred to using the dot first method. So pair is one entry from this unordered map, and the key for that entry is pair dot first. And pair dot second refers to the value, which is in our example, the email address. So no matter what kind of unordered map you create, the key is always going to be denoted by pair dot first, and the value is always going to be referred to by dot second. And this could be a structure. In our case, it is a string. It could be an object or whatever. Now, if you wanted to update an existing entry in the unordered map, that's also very easy. We know that there is an existing email address stored for Alice Johnson. We can just say the square brackets email directory square brackets Alice Johnson and set it equal to the new email address alice.new email at example.com. And then I'm saying that I have updated the email address for Alice Johnson, and I'm displaying that new email address over here just to be sure that it was updated. If you wanted to erase or remove an entry from the unordered map, you can call the erase function. And the argument to the erase function is the key. So since in our example, the email directory, the key is the person's name. I'm passing Bob Brown as the argument of this function. That's the key. And hopefully this would remove the corresponding entry. And I am in the end displaying the entries, all the entries from the unordered map, or in other words, our email directory. Look at this for loop that's iterating over the unordered map. It's a bit complex, it's a bit unwieldy, it's pretty long. And that is one of the reasons I used the range-based for loop from modern C++ over here. But just to show you uh, the magic that happens behind it is basically this. I say std colon colon unordered map string comma string. So this is the type specification for my unordered map. My unordered map has keys of type string and values of type string as well. And what I'm looking for is an iterator over that unordered map. So I carry on and I say colon colon iterator. Give me an iterator to this type. And I'm naming that iterator variable IT, initializing it to email directory dot begin. So it gets initialized to the first entry in the email directory. And my loop is going to keep going until becomes equal to email directory dot end, meaning it goes past the end of the email directory. And every time through the for loop, I'm going to increment IT. And inside the for loop, now since IT, the iterator is like a pointer, and it is pointing to what? It is pointing to key value pairs. And just as we observed over here, the key part is referred to through the first member variable, and the value part is referred to through the second member variable. In order to access first the member variable first through the iterator, since the iterator is like a pointer, I am saying the arrow operator instead of dot. Over here, pair was an actual object reference to be precise. But over here, this is not a key value pair object. It is a pointer to a key value pair. So we have to say IT arrow first and then IT arrow second. Let's see what happens when we compile and run this program. I'll compile the program using G++ and then run it. So let's look at the program once again to see what the program is displaying in the terminal. So the first thing that we had done was we had stored these 4 email addresses, and then we had searched for the email address for Jane Smith. So that is the first thing that we are seeing in the terminal. That email for Jane Smith is jane.smith@example.com. So that essentially means that this if statement turned out to be true, and we displayed the email address for that particular person. And then we had a for loop which displayed all the entries in the email directory. So let's look at the output for that particular portion of the code. And this is what we see. All entries in the email directory: Bob Brown, Alice Johnson, Jane Smith, and John Doe. So Bob, Alice, Jane, and John. If we look at our code, that is exactly opposite uh, the order in which we inserted these email addresses in there. And of course, these are not in sorted order. That's why we call this an unordered map. It is not sorted or anything. The next thing that our program does is update the email address for a particular person, which is Alice Johnson. Let's see what we get on the terminal for that portion. And we see that updated email address for Alice Johnson to alice.new email at example.com. Further on, what did our program do? We tried to erase an entry from the directory, and let's see what we saw on the terminal corresponding to that portion of the program. Bob Brown was removed from the directory, and then our program finally displayed the email directory to the console using this for. Let's see what we see on the terminal for this portion of the program. And this is what we see: final directory contents. And you'll see that Alice, Jane, and John are here, but Bob is not because Bob's email address was removed from the directory. So fantastic. So that is an example of how we work with the unordered map data structure. So here's a summary of what we've seen recently. We've seen an STL container named unordered map, which provides really fast access to data based on key value pairs. And it supports iterators just like the vector STL container does. And you can even use the indexing operator, the square brackets, when you want to read data or store data or update